Here's a cute little puzzle that fooled Einstein. Imagine this orange car going up a hill at 15 meters per second. At what speed must the car travel down the hill so that its total average velocity is 30 meters per second? You can assume the distance going up is 300 meters, going down is 300 meters, and so the total travel distance is 600 meters. Let's repeat the question. The car goes up the hill at 15 meters per second. At what speed must the car travel down the hill so that its average velocity over the whole journey is double the initial velocity? Without doing any calculations, what's the first answer that pops in your head? What does your intuition say? If you thought of 60 meters or thereabouts, it's wrong. As we'll see, it's wrong by a surprising amount. But don't worry, you are in good company with Einstein, who got fooled by this puzzle. So let's see how to understand this. The trick is to recognize that the hill is irrelevant. The problem is the same on a flat surface. Also, to see what is happening, it is better to think in terms of a distance d and a time t, as the actual values in the problem are a distraction. This is one of those problems where algebra gets you the answer more decisively than trying for an intuitive mental picture. We know that, as even Einstein's intuition failed. So if d is the distance traveling up the hill, the total distance is 2d. t1 is the time taken to go up, and t2 is the time taken to go down. The average velocity of the whole journey is on the right side of the equation. The question asked for this to equal twice the initial velocity, d over t1. So that's why 2d over t1 is on the left side of the equation. Now, as you can see, it is impossible to make the two sides of the equation equal. It's a trick question. To get equality means that t2 must vanish, making the velocity v2 down the hill tend to infinity. Now remember, there are no infinities in the physical world. Mathematics is merely a piece of machinery that spits out numbers, which humans need to interpret. In this case, the interpretation is that it is impossible for the average velocity to be double the initial velocity for this puzzle. Einstein elegantly framed this as there being not enough time for the downward journey. But what's happening? Why exactly is 2 times the initial velocity impossible? Why is it 2 and not some other number? Let's break this down. We can write out the 2 times, t1 and t2, in terms of distance over velocity, and the total travel time is then simply 20 plus t2. We know the total distance traveled is 600 meters. Now divide this by total time to get your average velocity. To investigate where the factor of 2 comes from, let's write x instead of 2. So we want the average velocity to be x times the initial velocity of 15. Plug that into the last equation and rearrange to get x. And here we see it is this 2 that is our culprit. As v2 gets very large, the 15 on the bottom gets swamped, and the v2's cancel, giving an x of 2. The 2 is a consequence of the total journey being twice the distance of the initial leg. Try the problem yourself with a different ratio of distances, and you will see the factor of 2 changes. To bring this finally home, let's plot x versus the velocity v2 in the downward leg of the journey. As you see, as v2 gets large, x asymptotically approaches 2. So how did Einstein react to this problem? Well, in 1937, Max Wertheimer wrote Einstein a letter giving him the problem. Einstein wrote back saying that the puzzle totally fooled him and that he only got it after writing out the equations. In Einstein's reply, he indicated that he finds these types of problems entertaining and that, quote, "Such drolleries show us how stupid we are." Here's an impersonation of his voice, imagining how he might have said this.
Such stories show us how stupid we are. Such stories show us how stupid we are.
If you want to follow up more on puzzles between Wertheimer and Einstein, I recommend this paper written in 1990, which discusses a number of Wertheimer's brain teasers. Did you spot the deliberate mistake in this video? I said the car was orange. It was actually red. Another thing you may have spotted is I conflated the terms speed and velocity. But this is a simplification rather than a mistake. For problems where the distinction doesn't matter, we can interchange the two. Now, here's something to ponder on. Not only are these types of problems entertaining, helping us to improve our math and physics, but they just as equally teach us about how the human mind works. So I'm always fascinated by problems that totally fool me. My intuition often gets fooled when I see a new puzzle for the first time. What have you learnt about the human mind through puzzles? Is it that we really are stupid? Or is it that our intuition is better tuned to maintaining our survival? What do you think? Feel free to leave a comment.